let's get into some more examples, not with the flowcharts. Let's just get into how you would see them on a worksheet or a test. So solve the following literal equations for the indicated variable. In A, I want to solve this for r, so I want to get the r by itself. Well, what are the 2 and the pi? What are they doing to the r? Since they're sandwiched close together and you don't see any operation symbols, you know that that's multiplication. So how do I undo multiplication? I'm going to divide both sides by 2 pi. That's going to leave me with r on the right-hand side, and r on the left-hand side, and on the right-hand side, I'm going to get c divided by 2 pi. All right. B, try on your own, and then I'll throw up the work in a quick second. Let's move on to C. C, we've got A plus B plus C equals 180. I want to solve this for A. All right, so how do I get the A by itself? What are the B and the C doing to A? Well, it's adding to the A, so I need to subtract B from both sides, and I need to subtract C from both sides. And so I'll get A equals 180 minus B minus C. Or I could get A equals negative B plus 180 minus C. You could rearrange this numerous amounts of ways, but something like 180 minus B minus C works. That's how you solve for A. Okay, as long as the 180 is positive and the B and the C are both negative, because you subtracted those over, that should work. All right, go ahead and try D. Pause the video and try that out. So try B and D, and let me throw up the work. Okay, that is what you should get for B and D. Have any questions, let me know. Other than that, we're on a roll. Let's keep on going. Let's do E. Okay, this is kind of like the one from the previous video, but we got 2x plus 5y equals 20. We're solving this for x. So let's get the x by itself. So let's work out in. First thing we need to do is subtract 5y from both sides. So we got 2x equals 20 minus 5y. To close this out, I need to get the x totally by itself, so I need to divide both sides by 2. So I get x equals, 20 divided by 2, that's going to give me 10. And then 5 divided by 2, I'm just going to leave that as a fraction. So 10 minus 5 halves y. Something like that works. Or negative 5 halves y plus 10, or 10 minus 2.5y. But typically I'll leave my answers as fractions for future things that we're going to get into. All right, if you think that you have an answer that you think is right and it doesn't match mine 100%, there's a good chance it could be right. So you just want to double check with me or try to rearrange your equation using like fraction rules or something along those lines and see if you can get it to match mine. All right, F, I want you to try on your own, but let's move on to G. So if you're going to try F, pause the video, and then because I'm going to move on to G. We got A equals pi r squared. Well, that's the area formula for a circle. We want to solve this for r, though. So the first thing I want to do is get rid of that pi. So to get rid of that pi, I'm going to divide both sides by pi. So I have A divided by pi equals r squared. Well, now we have to ask ourselves how I'm so close to getting that r by itself, but it's got that exponent of 2. How do I get rid of something being squared, or when I see that exponent of 2? Well, that's called a square root. So I'm going to square root both sides. All right, and that is going to cancel out the squared and leave me just with r. So radius, or the r, is going to equal the square root of a divided by pi. So if you see something being squared, to get rid of it, you're going to square root. If you see something being cubed, let's say, you're going to take the cube root. So you're just going to throw a little 3 up in that corner of that radical sign. All right, notice how there's not a 2 here. Okay, you could put a 2, but it's unconventional. We know that a square root, if it's just the radical sign, that has that little symbol of a 2. We understand that that's there. We don't have to draw it in. So just in general, if you have x raised to the nth power and you need to get rid of it, that little number goes outside the radical, and then you just put the radical sign. Okay? That might help you on some of your homework problems. All right, last one we're going to do is h. We have y equals negative 4/3 x plus 1. I want to solve this for x. So first thing I'm going to do is subtract 1 from both sides. So I have y minus 1 equals negative 4/3 x. So negative 4/3 is multiplying x. So in order to undo multiplication, I need to divide. However, remember, when we divide fractions, we multiply by the reciprocal. Okay, so I'm going to multiply both sides by negative 3/4. And that's going to leave me just with x on one side, which is good. That's what we're solving for. But on the other side, we have negative 3/4, and that is multiplying the entire left-hand side over here, the entire y minus 1. So I have to remember to put that in parentheses, okay? Because we're taking negative 3/4 and we're multiplying it by the entire thing, y minus 1, okay? We could also distribute it and get x equals negative 3/4 y plus 3/4. Both of these would be appropriate answers, okay? Because we can't simplify anything more than that. So the difference between h and e, the reason in h we could leave the negative 3/4 in front of the parentheses, is because we can't really simplify. If we were to distribute it in, there's nothing that we can simplify. Whereas in e, we can take 20 divided by 2. And so that's why we simplify that in e. All right, let me throw up the work real quick for f if you pause the video. That should be your work. Oops, I missed some of the work there. There it is. All right, so that's one for you as well. And then you see we have the negative 1/4 in front of the 28 minus x here. If I did distribute it, oops, get back to my pen, we could simplify it. And that's why I've got this answer right here, because we can take negative 1/4 times 28. So that's a lot of examples. Next video, we will knock out this word problem, and that should be it.